Okay, so we have a question under geometric progression, and this question came in paper 2 2023 in 10 when it was on question 3. So the question said, given that the third and sixth terms of a geometric progression is 3 over 4 and 3 over 32 respectively, find the question 1 first term and common ratio. Question 2, nth term, and question 3, sum to infinity. So the question, I'm going to repeat the question again, reads, given that the third and sixth term of a GP is 3 over 4 and 3 over 32 respectively, find the first term and common ratio. So let's find the first term and common ratio using the information given. So we have been taught that the third term is 3 over 4 and the sixth term T6 is equals to 3 over 32 according to the question. So now let's find the first term. So here the first thing that you need to do is to write the formulas for the third term and for the sixth term. So you know that the third term T3 is given by the formula. Okay, first of all, you should know that Tn is equals to AR to the power n minus 1. Okay, this is the eighth term. Tn is equals to AR to the power n minus 1. So since it's third term, this third term here, where is n? We're going to replace with 3 because n is 3. So we're going to have T3 is equals to A, we don't know A, to the power 3 minus 1, where this n we replace with 3. Okay, because it's the third term. So we're going to have T3 is equals to AR squared. AR squared. So this is the formula for the third term. Let's now find the formula for the sixth term. So we know that Tn is equals to AR to the power n minus 1. Where there's n, we put 6. Because we're finding the formula for the sixth term. So we're going to have T6 is equals to AR to the power 6 minus 1. Hence we're going to have T6 is equals to AR to the power 5. So in short, the power of R is less than by the term by 1 is less than by 1 to the term. So these are the formula for the third term. We find that T3 is equals to AR squared. And for the sixth term, we found AR to the power 5 as the formulas. So we know that T3 is 3 over 4 here. So where there's T3, we're going to put 3 over 4 is equals to, so 3 over 4 is equals to AR squared, okay? And this side, you know that T6 is 3 over 32. So I'm going to put 3 over 32 is equals to AR power 5. Okay. So since we know this, we can, so this, we can make it similar to this by expanding. So our aim here is to make this similar to this one. So we can make it similar to this one by expanding it like this. So we're going to have 3 over 32 is equals to, so 3 over 32 is equals to R power 2 multiplied by R power 3. So writing like this is the same as writing it like that, because we know that R squared multiplied by R3, we are going to have a situation like this, R squared times R3. We know that when we are multiplying numbers with the same bases, we just add the powers. Hence, we are going to have R is equals to 2 plus 3. It will give us 5 is the same as this R which has 5. So writing it like this is the same as writing it like this. And you should know that this part, which is AR squared, is the same as this part, because we know that 3 over 4 is the same as AR squared. So we can replace 3 over 4 because this and this, they are equal. We know the value for this one, it's this one. So we can write this one as 3 over 32 is equals to While there is this, we replace with 3 over 4 times r power 3, like this. Okay, so having written like this, now we can finish it by doing like this. 3 over 32, we just bring this one here is equals to, here we can multiply, hence we're going to have 3r power 3 over 4. Then we close multiply. Let's close multiply. So this multiplied by this, we're going to have 12 is equals to this 32 multiplied by 3. So 32 times 3, this and this, we're going to have 96. So 96 r power 3. 96 r power 3. So we can now divide by 96 by 96 both sides. Okay, so 96 over 96. So here in this will cancel. We're going to remain with r is equals to this and this. 12 can go into 96 8 times, and 12 can go into 12 1. So 12 into 12 it's 1, 12 into 96 it's 8. Then after reaching this side, you just find the cube root of this. You just introduce the cube root and the cube root. You know that this and so the cube root, you know that this cube root and this we're going to cancel. So we're going to have r is equals to, what's the cube root of 1 over 8? It's 1 over 2. By finding the cube root, we mean the number which when we multiply itself by 3 times to give us this. So it's 1 over 2. 1 over 2 multiplied by itself 3 times to give you 1 over 8. So this was our r. So this is how to go about this question. So having found our r to be 1 over 2, we can now find our a using one of the equation which we made. We made this equation, which is 3 over 4 is equals to r squared. Also, we made this equation, which is 3 over 32 is equals to r, is equals to a multiplied by r to the power 5. So we can just pick one of these and replace with the values of r to find the value for a. So let's go with this one, which is 3. So let's just create space. Okay. So our r were found to be 1 over 2. So we can just do this. 3 over 4 is equals to a multiplied by r, which is 1 over 2 squared. Remember here it has a squared. So when you expand, you're going to have something like this: a times 1 over 4. Okay, so a times 1 over 4. So here 1 multiplied by a, it will give us a. So we're going to have 3 over 4 is equals to a over 4. Okay, then we close it, multiply. This multiplied by this, we're going to have 4a is equals to 12. Then we make a the subject formula like this. So we're going to have over 4 over 4, hence we remain with a is equals to 4 into 12, it's 3. So this was the answers on question 1, where we are told to find the first term and the common ratio. So this is the first term and this is the common ratio. Let's now go on question 2, where we are told to find the nth term. So let's now find the nth term. So remember, we have found our a to be 3 and r to be 1 over 2. Okay, like this. Okay, so we know that the nth term is given by the formula Tn is equals to a r to the power n minus 1. So let's now find this nth term. Okay, so I'm going to have Tn is equals to our a. We have found that it's 3. So where there's a, we'll place 3. Okay, so 3 multiplied by our r, it's 1 over 2 to the power n minus 1. Okay, so our Tn is equals to it will be 3 multiplied by 1 over 2 to the power n minus 1. So this is the nth term. So this had 2 marks and the first one had 1 marks. So let's now find the sum to infinity. Let's now find the sum to infinity. So we know that we have two methods where we use to find the sum. The first one is sum to infinity is equals to a over r minus 1. We use this one when r is greater than 1, or a over 1 minus r. So we use this second one when r is less than 1. So we found our r to be 1 over 2. So this means that our r is less than 1 because this is 0.5 and 0.5 is less than 1. So we're going to use this second method. So let's go about the second method. Okay, so the second method which we're going to write is like this. Sum to infinity is equals to a, we found our a to be 3, isn't it? And over 1 minus our r, which is 1 over 2. So here you begin by dealing with this fraction. So we have a sequence like this: 1 over 1 over 2. So here we first of all we found the common denominator where 1 and 2 can go into 2. So we're going to find that it's 2. Okay. So we do 1 into 2, it's 2. 2 multiplied by 1, we're going to have 2. Minus 2 into 2, it's 1. 1 multiplied by 1, it's 1. So 2 minus 1, we're going to have 1 over 2. Hence 0.5. Since this is paper 2, you can just use a calculator. You can just do 1 minus 0.5, it will give you 0.5. So sum to infinity will be s to infinity is equals to 3 over 0.5. So 3 divide 0.5 to give you 6. So 6 was our sum to infinity. So 6 is the sum to infinity. Hence we have 6. So this is how this question was supposed to be answered. So sum to infinity is equals to 6. Okay, so this is how to go with this kind of question. So the last thing that we need to do is how to find the mean of a GP. So the mean of a GP is given by the formula B is equals to A multiplied by C over the square root. This, I'm just going to give an example so that you understand. So you are going to have a situation, maybe you have maybe let's say 2 and 8, and then they ask you to find the number which is in between 2 and 8. They will ask you find the number between 2 and 8. So you're just going to do so here there's B, which is this one which we don't know. So just going to do B is equals to square root of A, it's this one, multiplied by B, which is this one. So B is equals to this multiplied by this, we're going to have 16, as B will be 4. Okay. Okay, so B will be positive or negative 4. So this is how you find the mean for a GP. The mean for a GP.